Back at the Criff, the XRS team detects the first sign of problems.
So this is really what we're seeing. This is really the indication of trouble, of a leak, which is that when we close off the valve, the leak rate goes down. We open the valve, the leak rate goes up.
Sensors detect a small helium leak inside the dewar.
And we did another check over here as well. So this step here, from this low level, which is almost zero, up to here, is our leak. That's the real solid indication.
We had a very small leak, and it was so small that it was almost impossible to see at room temperature. It was only when you made the system very cold that the leak would get big enough that you could see the helium coming out.
That has a couple of implications. First of all, obviously, is right now we have an extremely tight delivery schedule, so this now potentially jeopardizes the delivery schedule. All of the instruments that we build for use in space are one-of-a-kind, very unique instruments, and so we allocate some time in our schedule to deal with problems and unexpected things. In this particular case, we're dealing with something that's really difficult. We have a very, very small leak that we can only detect when the instrument is cold, and therefore it's going to take a lot of effort and a really heroic effort on the part of the team to try to find this problem, fix it, and get the instrument back together and into Japan when we said we would.
As the XRS team races the clock to solve the helium leak, the X-ray telescope manufacturing process enters another phase, testing.
We've now gotten foils that have the front surface we want, and it goes into the metrology lab where the foil is inspected.
A WICO profilometer measures using light, so it's a non-contact method. It uses visible light to actually measure the roughness of the surface. As far as X-rays go, these are pretty close to mountains. But these are very short mountains, being only about 1/1000th the height of a human hair. So we would like to have them just basically as small a difference between the maximum and minimum as practical.
So then they're graded, some are rejected, some are what we call flight, and then some are put in a small class of usable if you have to get yourself out of a jam.
All the parts are ready.
So we're going to start building up a telescope, and we do this one quadrant at a time. After you've put the bars in, you put one foil in the middle of the housing somewhere, and you put it on an alignment fixture. The alignment bars are the ones that create the angle and perfectly position the foils in the housing. Make it so that we can stick one housing on top of another and have 175 concentric nestings line up perfectly with 175 below.
After spending days in an exhausting effort to fix the helium leak and stay on schedule, the XRS team now faces an even more serious problem.
There was a leak which turned out to be in the vent line, and we found that with this leak detector, and we're able to patch it and repair it. And unfortunately, what happened was during the testing of the repair, we got an ice plug in the helium fill and vent lines for the test dewar, and that actually ruptured and caused some damage. This, of course, has set us back quite a bit.
The XRS team goes into crunch mode, with shifts working around the clock to fix the damage, test the system, and get back on schedule. It's become the most grueling, the most trying few weeks the XRS team has had to go through. Tension strains the team, testing nerves and patience.
It's not a joke. Calm.
No, it's actually it's a Goddard thing.
I'm calm.
The mirror team had its share of problems too. Early on we had some structural problems. In a couple of cases, mirror assemblies did not pass vibration testing, which simulates the rigors of launch. We went in and made repairs to the assemblies and retested successfully.
The X-ray telescope quadrants are ready for more testing and final assembly.
You're seeing the edges of the foils in many, many arcs like that. That's the 175 nestings. So then you got a quadrant. Now we're going to do some optical testing with that, and then we start doing X-ray testing with it. And so what we're looking for is to contain the photons in as small a circle as possible.
The better the focus, the more photons will arrive onto the XRS.
So the process is done again in optical and white light by putting the 4 quadrants on the ring and then looking at where each quadrant projects its image and adjusting these until they all project to the same spot.
With the assemblies complete, the telescopes can be packed and sent to Japan for further testing and final assembly onto the spacecraft. It's been a tough few weeks for the XRS team, but their determination and drive to stay on schedule pays off.
So we're going to deintegrate the FE80R this morning. We should be done in about an hour and a half. And then that ends this series. And then we're on to the cryostat integration. Back where we should be. People are a little bit happier than they have been over the past few weeks because we made a new schedule after we had the accident, the damage to the test door, and it looked like if we really worked hard, we could get done in time to deliver in mid-March, which is when we need to deliver in order to launch on time. We've actually gained on that schedule. We're 6 days ahead of that schedule right now, and that has some slack in the schedule as well. So we've got a little bit of room now to breathe. So everybody's feeling a little bit happier. It's really nice to be done with this calibration, the interim calibration, and going back into the real flight unit.